My name is David Magar. I am a senior program manager on the Power BI team. I focus on making Premium a better platform for everything that it needs to support. So you've seen some awesome announcements yesterday and today about really cool features. Some of them are supported only in Premium. Some of them are better with Premium. Some of them are the ultimate things lie spread on Premium. And the nice thing about this is that with great power comes great responsibility. And I really wanted to have a slide with Spider-Man saying it, but I can't because of copyrights. So I'm just going to say it. And the focus of the session is to kind of provide just a bit of highlights about what the great power is. And at the same time, give you an understanding of what great responsibility means, because there's a lot to it. Now, just a show of hands, how many of you were lucky enough to attend the workshop yesterday by me and Swali? That was good, of course. Okay. So there is some overlap between the two sessions. And it's really hard to stick it all into 60 minutes like we're going to do it here. And this is why there's more content over there. But I do cover more stuff on this session. And so it's really great that we prepared a related sessions slide so you can take the slides with you at home and know that when you read this, you should read other slides and get some more reading. So at least you understand association, right? So now I'd like something from yesterday. Please keep it in the audience. Don't ruin the joke, all right? So I want everybody to think about a movie for 3 seconds. 3, 2, 1. Think of a movie. Now think of another movie. What movie do you think about? Very good. Okay. Who remember the first scene of The Lion King? Exactly. What song is this? Circle of Life. Exactly. You in the audience. Are you familiar with the content? Okay. So this is the Premium Capacity Lion. He is a friend of the Paginated Report Bear. If you guys are on Twitter, they are good friends. The lion is stronger than the bear, of course, because he is the king of the animals. Now the slides don't click. I'll click again. So what we're going to talk about is basically why choose Premium, how Premium works in a nutshell, and a lot about something new that we call EMAP, or the Circle of Life. This is the Circle of Life for Premium Capacity. It has 4 major steps that you constantly need to kind of undergo to make sure that Premium keeps working and functioning the way it should. So it's evaluating, adapting the content. We'll touch about in monitoring and prevention because we talk about them in a bit more length in the other session that I had yesterday. So this session is basically around these pieces of the Circle of Life. Then we do some wrap-up and tips, and hopefully we'll have some time for Q&A if I get through the 30 slides that I have for you. So, that's that, the line. So why choose Premium? You are about to renew your enterprise agreement, or you get a new one, or you never were a Microsoft shop and you want to become a Microsoft shop. Now, should you choose Premium or not, just get pro licenses for everybody. How do you know? So Power BI Premium is an awesome platform. It has 4 main pillars that it provides. The first one of which is the flexibility to license by capacity. The basic economics of it is that if you have 500 or more users, then you're better off having a Premium capacity than not having a Premium capacity because it's just more economical. So that's simple. There's greater scale and greater performance with Premium that is obtainable. That necessarily means that you'll get there. It's really depending on what you want to do with it. You get support of larger data sets. You get support of more frequent refreshes. You have incremental refreshes, which provide you faster refreshes for large data sets. You have aggregations, which allow you to query infinite sizes of data sets, basically based on Spark clusters. And query caching for really fast rendering. We are unifying a lot of the concepts from the self-service BI world and the enterprise BI world Obviously, you heard about paginated necessary reports that are GA'd since yesterday. This is the classic centralized BI feature available only in Premium. AI and predictive analytics, pervasive, but much more capable in Premium, where you can run larger scale data flows and have fast and more frequent refreshes for data flows using these AI functions. Programmatic access to your Power BI content through an XMLA endpoint that is available on Premium only. Right now, it's a read-only preview. In the future, it would be read and write. And a lot of enterprise-grade compliance features. So we disclosed Bring Your Own Key yesterday. A blog post is going to follow shortly where you will learn more how to actually turn it on. We have multi-geo capabilities right now that are FGA'd a few months ago. Together, there's a real suite of features that allow enterprises to meet very strict regulations and compliant requirements, no matter where the data needs to reside, and no matter where what types of encryption or added measures you need to have on your data once it's in the cloud. You probably can achieve it using features only available in Power BI Premium. So if you have strict compliance requirements, Premium is definitely something to consider. And we're extending on-premise and cloud with Premium, where we provide, obviously, licensing to both PBI Report Server, and Premium capacity in itself is a dedicated resource in the cloud where you are not sharing any of your processing or your data storage with any other tenant. Coke and Pepsi do not live together, neither does any other competitor that uses the cloud. And is anybody from Coca-Cola here because they're in Atlanta? No? All right, so let's provide a bit of a background just to level set everybody what's taking resources in Premium capacity. So you buy basically vCores or vCPU. The cores in the Premium capacity are sharing their cycle, their time slots with all of the operations that the capacity needs to do. And so that means if I have 3 running reports that I need to render at the same time, the CPU cycles will be shared between rendering 3 different reports. It will process 3 different data sets, one at a time. And if I have 4 cores, that's basically distributing I can have one core processing one data set, another core processing the other, et cetera, et cetera. Memory is required for hosting the data model themselves. Basically loading into memory, so that's something the CPU can read of something. It doesn't read it from disk. That's why it's so fast. It's required for being a scratch pad for the calculation that your data models have. So DAX expressions in Power BI reports can be fairly complex. They need to take some rows, takes some more rows, multiplies them, join them, all those fancy stuff. This requires memory as well, and is in comparison to hosting the data model, which is very predictable. I mean, once it's in memory, then that's the static data model. This is rather unpredictable because it's very much associated with whatever the people writing reports in your organizations wrote as DAX expressions. So it's really, really hard to understand in advance how much memory will these expressions require. And so if I have 3 reports running on rendering on my capacity, I need to host 3 data models and allocate some room for 3 operations at the same time. Each operation space kind of dependent on whatever was written on the Power BI report. Sorry. Okay. So beyond CPU memory, we have limits and caps that are embedded into the capacity. And the reason we have limits is because Premium capacity is optimized to render reports. And because Power BI allows you to perform 2 types of main operations, which is performing queries or rendering stuff and performing refreshes, and we don't want the refreshes to ever kind of tramp everything. And so we limit the amount of concurrent refreshes or parallel refreshes that a Premium capacity can run based on the size. P1 can run 6, P2 can run 12, and a P3 can run 24 at the same time. Now, this doesn't mean that 6 is not enough. It means that it's just if your refreshes take 10 minutes, you'll be able to run 6 refreshes that take 10 minutes 6 times during an hour. So it still gives you plenty of refreshes space. It just means that at the same time, some refreshes, if everything is scheduled at the same time, some refreshes might wait for others to finish before they kick in. And that can generate some phenomena, which we're going to see, talk in more depth in the previous sessions. But basically the phenomena that refreshes can wait. Sometimes they wait too much because people have scheduled the refreshes all at the same time, and then somebody was eventually not content with the fact that refreshes wait. So this is one limitation that is very frequently being kind of observed and misunderstood. So it's very important to kind of level set that. The other limitations that we have is, of course, the amount of data in memory is capped based on skew. So all of the reports loaded into memory on a Power BI premium capacity take no more than 25 gigabytes on a P1 or 50 gigabytes on a P2 or 100 on a P3. This is not the capacity's ability to host reports. You can publish 100 terabytes worth of data onto the premium capacity. It just means that all the reports that can be rendered at the same time need to consume no less than 25 gigabytes. Now, you can achieve reporting over larger amounts of data regardless of memory using features like aggregations, where some of the reporting is done over data not stored in memory. It's stored somewhere else on a Spark cluster and things like that. So it doesn't really mean, again, a data cap. It just means the amount of memory is somewhat limited. And the way the thing that Power BI introduces in premium capacity that never existed before in products like analysis services is actually evictions. So with a 25 gigabyte memory, if we see memory pressure, we take the least frequently visit report and we take it out of memory, and we bring the newly requested report into memory so that you guys can basically render it. That's how, with 25 gigabytes, we actually achieve a lot of availability, even though the sizes of the data modeled in the report on this could be a lot larger than 25 gigabytes. So forced evictions take time. We need to dump stuff back to disk, read stuff back from the disk, load them into memory. And all of these things take time, and they may slow the capacity down or slow the operation of rendering down. So you don't want it to happen too frequently. But if it happens, it's a by design feature. It's perfectly okay. I mean, it just means that you reach the point where we need to take something out and need to put something back in. If it happens too much, you need to reconsider. So we talk about what too much means exactly. How does this thing look on an illustration? If I have the 100 terabyte storage, 25 gigabyte memory on a P1 with 4 vCores, 3 data sets are loaded into memory, 3 reports are being rendered right now and viewed by users. The capacity is kind of cool and everything has room for growth, and it's great. Eventually, I got to a point where all 25 gigabytes were filled up with 6 data sets. And the 7th data sets want to come along. The least frequently visited data sets are data sets 2 and 4. And basically, the capacity flags them as evictable. So it will now evict data set 2 back to storage and load data set 7 in its place. And great, we have room to function. Now it's kind of a more warm capacity, but still functioning very, very well and by design. I mean, nothing is slowing down too much. Everything is great. Now, what happens in the refreshes? As we say, we have 6 parallel refreshes. If 6 are running and the 7th wants to run, he waits. He waits in the waiting area, or she. I don't know if the refresh is a he or she, but it happened. They wait in the waiting area and wait for basically for one of the refreshes to complete. And once they complete, refresh 7 fills its slot, and everybody's happy. So this concludes kind of the level setting piece. I really went fast through it because of the interest of time. Are there any questions that somebody? Yep. No, there were benefits of Power BI in general. Azure Analysis Services is not really a SaaS service. It doesn't provide you the value of a front end. So it's kind of comparing oranges to something else. Yeah. No. 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 Yeah. So premium is strategically better than Azure Analysis Services. That's the vision of premium. And there was another one here. Yeah. Yep. No, no, not at all. So yeah, reports in Power BI are hosted inside workspaces, and users with free licenses can authenticate against Power BI front-end service and use the service like anybody else. They can only see workspaces that are hosted on premium capacity on premium capacities, and they can see them through apps. And so the app sharing model, the app publishing flow, is basically the distribution mechanism inside the service for users with free licenses, right? Yeah, the workspace, all content that is consumed with a free license needs to reside on a premium capacity, which means the workspaces need to be hosted on premium capacity. Yeah, and then they're limited like regular pro license, like no more than 1 gigabyte, no more than a few refreshes a day. Um, uh, Data in import mode is faster than live connection. Than that. I mean, and Live Connect is as fast on Pro as it is on Premium. It's no different. Yeah, if it's the same. Yeah. By the way, aggregation. Hmm. So there's a walkthrough I'm doing for in-memory scenarios, which you think is straightforward. A lot of people don't get. The cap we are recommending is 35% of the data set size to be reserved for like operation. That applies for the direct query as well. We have no other rule of thumb. It's very much related to what are the actual calculations. The limits per second of. Oh, okay. Yeah. They're not listed in the slide. But okay.
Just one related query to the right query actually. The 1 million row limit. Are we planning to lift that?
That's actually. Can it prevent? Yeah. So there's a slide about that. But yeah. Wait with that. There were a few more over there.
We're in the West region. We were told we're in like an old saturated data center. How much does data center affect premium capacities in different regions?
So the SKUs for premium capacities are mapped to certain machine types in data centers. We are working hard to mask all of the data center, the Azure kind of data center limitations from customers of premium. You should not be concerned about it, basically. If we support like a P3 on everywhere, then we support a P3 anywhere, and we find the means to achieve it. Yeah, like, but your Azure account is telling you that, not your Power BI account, I imagine. Like,
are you saying who said it?
Yeah.
Adam Saxton.
Oh, okay.
I hope I didn't get him in trouble.
All the public data centers on the same market.
Yeah.
There is a West. It is an older hardware, but.
Okay.
Interesting. Okay. Anybody else on that? I saw a show of hand, but it was imagined. Okay. So, what is the timer? No timer. All right, 35. Thank you. So let's go back to the circle of life, right? And the first stage of it is evaluation. Now, if it's trivial, then skim through it, but if it's not, I won't skim through it. Let's talk about evaluation. First of all, we need memory for rendering the reports. That's memory, like to load the reports into, to load the data sets into, basically, right? Then we need memory for refreshes. Any report, any data set we're going to have in Power BI, we want to refresh once a day, once an hour, or 2 times an hour, we don't know, but we need memory for refreshes as well. Now, what happens when we refresh is we spin up another copy of the data set, and we load both into memory. And so if you happen to render a report of that data set when the data set is being refreshed, we use one copy, and we perform the refresh on the other copy, and when it completes, we swap them, and we don't need the other copy anymore, right? So basically, you need twice the size of a data set to perform a refresh. And last but not least, memory for operations. We recommend that would be 35% from both, basically. So that's kind of the strategy to do the planning. Now, the question is, how do you translate that into actual scenarios where you can go and do the calculations to reach a conclusion? I need a P1, a P2, or what do I need in my organization? So let's imagine a scenario where I have 4 reports, and I have the data set size of each report be of different kind of size. The first one is half a gig. The second one is 1 gig, 1.5 gig, and 2 gigabytes. Now, the way to understand what the data set has in memory is not to look at the file size of the PBIX report, is to actually load PBI desktop with that report and look at the memory footprint of a process called MSMD SRV in your task manager. That's basically analysis services engine running on your PBI desktop, and the memory footprint of that engine is the same memory footprint your report is going to have when it's loaded in the capacity. That gives you an understanding of how much this is really requiring even before you buy premium capacity. So now, beyond just sizes of the report, I have a production workspace where the CFO and the CXO and the CMO and everybody will kind of look at the report and send us angry emails when they're not refreshed, or send us like happy emails when they are happy, and so that's a workspace probably. So that has a copy of all the report. Of course, there is the BI team that keeps developing and testing new reports and new versions of the report and new measures and new visuals and new relationships, and they keep messing stuff up and not messing stuff up. But these guys need their own workspace, and they want them to not interfere with what the CFO is looking at. And so we need 2 more copies of everything, probably, just to get things rolling. So that gives us kind of this kind of 12 instances mapping of these reports. Now, requirements. Usually refresh frequency is a strong requirement in an enterprise environment. So I imagine production workspace, being the CFO, requires data to be no older than 2 hours old. And so 12 refreshes a day would suffice, basically. The others are basically developer driven, so they're kind of ad hoc report. You don't know when they're going to be refreshed, because they're going to be refreshed when the developers are going to refresh them. And so the production workspace, of course, needs to be hosted into memory because the executive team is looking at reports. Then in the worst case scenario, we're going to have to load both the test workspace and the dev workspace content just for viewing, right? Because it's now 10 a.m. and everybody's in their offices and they're working. And just that alone means we need 12 instances of reports loaded into memory, right? Now, we need to examine the worst case scenario to understand what we actually need here. So let's take a case where all 4 reports are being refreshed in the production workspace, and that happens every 2 hours, right? So that gives us the mapping here. This was 15 gigabytes, just that piece, I forgot to mention that. Just doing the math on memory for report rendering, we get to 15 gigabyte of in-memory requirements, right? Now, considering refreshes, the production workspace will need to load it into memory with this separate instance all at once, and that gives us another extra 5 gigabytes, and we're already at 20, right? Now, picking the worst case, the two larger ones could be loaded into memory as well, which is 2 instances of D, and then you have 1 C. And together, they already bring us to 5.5 gigabytes. And that basically pushes us beyond the P1 limit. Now we're at a P2. Basically, that's saying we're going to have 25.5 gigabyte memory requirement, and that will be met only by P2. Now, when we said all of that, we can conclude that with a P1, if we choose to go with a P1, we will be able to work with the memory we have for report rendering, but for refreshes, we might wait sometimes. Now, this could be a result that everybody's okay with. I mean, you can choose to be okay with refresh wait times. It just need to be a mindful decision that you make and you communicate so that nobody is expecting refresh to work like more frequently or better than it can on a P1. Now, what we didn't do right now is we forgot about this guy. And so even if we do all the calculations and we think we're good enough with a P1, if you start amassing the 35% headroom that is recommended, and that's basically a ballpark estimate because it's very much dependent on the good or bad DAX expression that your organization can write, then that is not cutting it anymore. And that pushes you over the edge from P1 to a P2. And so this is an example of how to perform kind of thorough and basically production ready capacity planning in terms of memory. And it's something that most premium customers don't do very well at their first iteration, and then they find themselves hitting the limits sooner than they thought, and that's what's driving it, basically, not considering all the scenarios. So it's a very important takeaway, kind of to internalize the walkthrough. Yeah. So rendering click precedence all the time, such that we will even pause refreshes if memory pressure is high, and the rendering requirements just keep coming for various data sets. And we show that in the previous session as well in this animated walkthrough, so you can kind of look at that. What was the question? Oh, that's a almost impossible to answer question.
Not use,
Yeah.
if you're using it in parallel, 100 gigs, 100 gigs of
So, yes.
no.
At the same report or a different report? Same report? No. No, not at all. No. So what we didn't touch here is what counts as a data set. So a PBIX is mapped to a data set when you publish it into Power BI. The various users using the same PBIX are all loading one data set. Okay? They can even get different results if the data set has a row level security in it. Doesn't mean that we're multiplying the data set. It just means we're calculating it differently for each one. Right? That is rendering. But that's, if you have 100 users running a 100 megabyte report and they're all using the same report, you got 100 megabyte of memory.
And it's really the same data set. So if you have multiple reports in the same data set, that data set gets loaded one time.
Yep. The only reason we copy it is when there's a refresh. That's when we multiply data sets.
For a full refresh.
Yeah. Yes.
Yeah, so for a full refresh, we keep it online so it can still be queried, which means there's 2 copies of it if you're doing a full. And then once it's done, the original copy is replaced with a new copy, and that double copy goes away. If you do incremental refresh, you only need to have enough memory for the incremental load, not the whole thing.
Incremental refresh is so we're showing that in a second. Basically, we're touching on how to improve this statistic. Anybody else? Yeah. Great question. Data flows. have a container that they're compartmentalized to. The default container size is 700 megabyte, and that's basically the memory footprint of a single data flow, or the max memory footprint of a single data flow when it commences. You are able to set the overall amount of memory that data flow process can consume. So that default value today is 5 gigabytes, 20% from P1. And that means you can run as many data flows that fit in a 5 gigabyte limit. So if the container size is 700 megabyte, you get 5, right? You get 7, sorry. So that's how data flow works. I'm touching about that in a few slides as well.
Yeah, that's not the CPU.
Touching that, and they take CPU as well. I'm touching how data flow, of how other workloads interact with the regular kind of Power BI workload in a second. All right, let's continue. So, yeah, slides up. Much more difficult to predict is, will your CPU meet the requirement that you need to meet? And the reason it's much more hard to predict is because you do not really know what's going to be written in the reports in advance. And if you do know, it's really hard to map it to like 4 cores on the back end, 8 cores on the back end. How much do I need? So instead of trying to say that in advance, what we built and released for this convention is a load testing tool. We have the author of the main tool right here in the audience with us. We should feel very privileged. This tool is basically a set of PowerShell scripts that wrap a HTML file that I'm going to show you in a second. So here's my PowerShell. You're not seeing the PowerShell.
Okay. Yeah.
Yeah, I see. Thank you. It's a different shell. Okay. So just look at the content of this directory. We have a PS1 script called initiate load, an HTML file, and some JSONs, and a README doc. If you go to that link that you just saw, it's going to be a GitHub repository that lets you get that into your machines. It is an unsigned script, so you have to set execution policy on your PowerShell to be unrestricted. We're sorry, but this is what it is. Let's do a walkthrough of what it does, right? So I call initial loads, and basically what I choose now is how many reports I want to run simultaneously. What I get from this tool is basically how many instances of X reports I choose as a representative example of the load I want to test for can run on my capacity in a time frame. And it's going to actually run from my machine. I'm limited by my machine because it actually needs to open browser windows. So don't choose the oldest laptop from your enterprise sitting on some desk to do this. Choose something with some memory in it. So let's do it just for kind of 2 reports simultaneously. We'll have some nice concurrency into it. You log in with the credentials you want to test for. So basically, you can choose to use the same report with different credentials, and then you actually test for row-level security. So you can basically mimic the exact scenario you're talking about 100 times if you need to. All right? When I log in, I get to choose from the list of workspaces and for this credential the report I want to test for. So in this case, we have W1 and P1 and W1, P2. Those are 2 identical workspaces that exist in a P1 and in a P2 capacity. You get a feel of the differences in number of cores and how it affects basically simultaneous processing. So let's get the same report from both. You're going to see it on screen. The P1 first. There is a data set called fast. Let's choose fast. And the values. So what you need to pass next is a set of values. Those values are filter values that the tool is going to cycle through as it does the load test. The reason we need to pass on filter values is because if we won't pass on filter values, and Power BI is not stupid, it will just use its own cache to show you the report. And if things will increment very fast, but we won't do any rendering, so we didn't really generate load or tested anything. So we keep passing a different filter value from in a cycle manner from these values to make sure the reports keep getting fresh, and we never use a cached query results. So that was the first report. Let's do now the last prompt is how many instances. That means how many different users are going to look at it at the same time. How many browser windows need to render at the same time. So let's choose 3 for this report. So we'll have 3 browser windows for this report in the P1 capacity. Now we'll choose the second report. We'll follow the exact same process, only choose the P2 capacity this time. Choose P2. The workspace is called fast. Right? Fast. Same values. And again, let's do 3 simultaneous rendering, right? Now observe what's happening.
Is that 3 simultaneous users or 3 simultaneous renders?
3 simultaneous renders. To get simultaneous different users, you need to use the tool differently. But now we're doing renders. And what happened to it? Final summary of the results. You see 2 configured report paths. Basically what happens with the tool is it dumps a JSON file that the HTML file reads to populate these automatic refreshes. So just a piece of information, not really required to understand what's going on. Now we have Chrome browser windows opening up. You have 6 of them. I'm going to, there they are. Okay. Here's the report. You see the counter on the top? It's getting incremented with every render of the report. Now, what's nice is you're going to see a difference between the 2 counters. One will increment a lot faster than the other, and those are the P2's one, basically, right? So you see this, here I'm in 4, and here I'm in 2. And this is going to go on. And basically, as time goes by, the counters will go further apart because one capacity has more cores, so it can handle simultaneous requests faster. Now, when I said cores are used to run queries, each visual here is a query on its own. So when you see a report with basically each spinning value is a visual. So we have 4 spinning values. Each render is 4 queries that are being sent to the capacity simultaneously. And we have 3 windows, so that's 12 query in an instance running against each capacity. So obviously a capacity with 8 backend cores to run these queries will perform faster than capacity with 4 backend cores that need to run the same load, because at some point in time, the one with the 4 cores, queries have to wait for others to complete, and it happens less frequently on the P2. So you're kind of seeing it against your eyes in the kind of real time. Any questions about the tool? You think it's going to be useful in your kind of planning operations and basically level setting management to what are the actual requirements of a premium capacity is? Anybody thinks that you are better prepared now? Please raise your hand.
Are you going to mention
Thank you.
SQL Profiler?
Oh, actually, we can. Thank you, Sergey. So I just don't have time for this.
While David is loading, want to make sure you guys are aware. Your premium endpoint, you can connect endpoint, you can connect tool endpoint, you can connect tool endpoint, you can connect tooling to it, such as SQL Profiler. So all those queries are fully traceable. You can actually literally see what's hitting the backend. And you brought up RLS. You can actually see effective username as part of your request.
Yeah.
In the RLS context.
I'm showing it on screen right now. So basically, we can connect to the P1 right here, right? That's the same credentials. And we are using FAST now. So I'm connecting now basically through XMLA just to the FAST data set on the P1. And these are going to be the trace events. Yep, query begin, query end, right? If I'll pause them, you'll see the CPU time. Second. Now we can actually scroll it. You can see what is the DAX expression, what is the SQL expression, what's the duration of the query, what's the duration on the CPU. There's a difference between the two because queries wait more on the P1 because there's a lot of queries coming, right? And that difference would be less apparent on the P2. So basically, we're actually hitting the capacity and we're not fooling around. This is actually doing it. Now the difference is like 84 on the P2 and 24 on the P1. You see it just growing and growing. Yeah.
That is on analysis services, yeah.
Yeah, it exists. XMLA is a standard protocol, and we exposed it in Power BI Premium recently, but it's a standard protocol that analysis services has initially. You could use the tool against direct query, actually, can't you?
Yeah, you mostly want to measure the queries per second, and
That's
make sure you stay under 30 queries per second if it's a P1, 60 queries per second if it's P2.
The data source will limit you, but no?
No, it's more of a licensing requirement that you stay within those limits, but you don't have to stay with them constantly. If you can go a little bit above, but the idea is to basically average below those. 30 queries per second on P1, 60, 90, it just keeps going up, doubling each time.
Okay, will the tool not work against a report based on direct query?
It'll work, but you have to count the queries from the other end.
It will work if you need to use the premium app
Yeah.
and see the query weight, right? Because
Yeah.
capacity will still dispatch. It works like a relay.
Yeah.
In that case.
So, I mean, you can use the load testing tool to get a benchmark, but you still need to stay below the limits that the premium capacity has in general. You can spike occasionally beyond 30, for example, but in general, stay below 30.
The tool would also be good for testing your performance on your direct query sources to make sure your direct query sources can actually handle that load.
Any other questions? I saw some hands. No. Okay, great. So that was the part about evaluating CPU. We have more content to cover, so bear with me. Okay. So, considering workloads, there were questions about data flows, and that's basically how they all come together. Workloads are turned on by default right now. We have both data flows and paginated reports that have GA'd, and they're on for all capacities. They consume up to 20% of the capacity memory by default, unless you change that setting in the admin portal capacity settings page. Each one of them individually. Each process is allowed to consume up to 20% of the memory in the capacity. Now, when they're not active, they're not consuming anything. And what we did with the CPU allocation is we basically went with the guidelines of we prioritize for rendering, such that workloads that do only background operations get guaranteed less CPU cycles than the workloads that perform interactive operations like rendering. So paginated reports, which people render like they do PBIX reports, can operate at the same speed that the engine required for rendering PBIX report does, then data flows can't. So data flows can't trump basically the ability to render reports, even if you have a lot of them running at the same time with really complex operations. And that's basically the guardrails that are built into the capacity. I believe it was you who asked about data flows. Okay, so Okay, so that's basically how data flows and report rendering kind of interact. Data flows cannot defeat the capacity's ability to render report. They can just, consume a bit of CPU all the time, but not disturb it too much. Okay? No, they do not. They all use the same engine, right? The same cores to run their engines. SSRS is its own engine, as PBIX is a different engine, but they're all running on the same CPU cores. Now, there's a bullet about overcommit, which is what can happen if you essentially load all of the workloads with a lot of operation and everybody's working at their 100%. So imagine you have 20% of SSRS reports, paginate reports, 20% of data flows, and 100% of regular Power BI reports. That will push you into 140%, right? So overcommit is possible. And we allocate for a bit of it with our own kind of machine memory management inside the data centers that we host. But you can reach to a state when if you change kind of the default values of the memory allocation for workloads, you will exceed our ability to kind of absorb whatever overcommit you may have got yourself into. And in that position, things may basically page to disk. Some of the memory requirement may page to disk on a premium capacity, and things might work slower than they used to. So the capacity will handle it, but it will just slow operations down, and it's very hard to predict which workload will be the one that is going to basically absorb the slowdown, but things might slow down. So notice that there's a disclaimer in the UX of the capacity admin where we change memory allocation. If you go over certain values, you may bring yourself to a potentially slower state, but only under load. That makes sense? Any questions about that? Great. Yep. Yeah, workloads cannot be off. Yeah. But then users cannot publish to workspaces on that premium capacity a data flow or an RDL file. Right? That's the idea. I did an illustration of how it works. I forgot about the illustration. Now, this is so the purpose of the bear was to show the paginated report bear and how the lion is taming the paginated report bear. So that was a joke. I forgot about it. Yes. Yes. You even should. They're less capable. So again, each workload behaves differently. There's different technologies involved. For paginated reports, allowing less memory is allowing less data to be read in order to render a paginated report. In data flows, it's less simultaneous running data flows. So the effect is less apparent in data flows than it is on paginated report. But it's all based on technology, and they're all different technologies. That make sense? Yeah. Okay. So with self-service BI scenarios, which is what you're going to probably experience when you deploy Power BI in your org, it's very hard to predict what's going to happen there. And we cannot do the centralized BI cases that we did just before, right? So how do you know what you need? You keep using the circle of life, and the next step in it is to monitor. Now, I touched a lot about monitor in the previous session, and I don't want to do it here because it would be too much time consuming. But what I do want to highlight is there's a premium capacity metrics app. It looks kind of like this. It has a tab for each workload, a number of pages in each tab that lets you understand that for each workload, the two operations, which are queries and refreshes, have ample enough resources to perform what they need to perform. Understanding kind of how to understand that there are ample resources for each is a topic on its own, and I don't want to just steal all of your times. Go to the other session that we had yesterday, the workshop. It will do that in much more depth. And we even use the load generating tool to kind of create interesting examples and look at their phenomenal manifesting in the metrics app. So you kind of see the whole end-to-end. I do kind of highlight some in bullets things you need to understand that you know how to look for those in the metrics app. So understanding query durations that you need to evaluate, understanding that queries can wait, understanding what the dataset sizes really are in memory when you look at the metrics coming from the app, looking at refreshes, wait time, and query wait times, understanding when there's too much of those. All of these are discussed yesterday, and there's also a very good white paper available on the Power BI documentation that has a section called Exploring Real-World Scenarios. This section talks about identifying these cases in the metrics app. So adaptation. Optimizing content is super important because it means that the content will consume less resources and will be able to scale better on Power BI. There are two very important sessions that happened in this conference, 2011 and 3052, which will happen at 1 o'clock today. They talk about, real kind of 300 level walkthrough of identifying unoptimized cases and seeing the effect of them both in the metrics app and in like real life when you're using Power BI, and doing the iterative process to make sure that these pitfalls don't consume too much of the resources. Look at these sessions and fully internalize them, because that would be one of the key drivers for Power BI success or successful deployment in your organizations. Now, beyond just writing good content, there are a number of features that are available predominantly in Premium that will allow you to be much more efficient than just naively using Power BI reports from your desktop and publishing them. First one, we already touched about incremental refresh. Incremental refresh takes only the delta of the data set that needs to be refreshed and loads that into memory. It needs to be configured through the Power BI UX. That's the UX that you see up here. You basically tell it to update the last week, the last day, the last few hours, and that's the only thing that gets loaded into memory. And then we don't need a full extra copy of the data set. That means that there's a lot of less memory requirements on the capacity. Second one allows you to require less queries, because data query caching is a property of the data set that you can set only for data sets that reside in workspaces and premium capacities. And when you set it on, then all of the first page visuals for each report are being cached. So it's enough for one user to come in at 9:01 a.m. and all other users at 9:02, 9:03, 9:04 will see the first cached page, and the queries will just never run on the capacity. So that will really reduce your query count. Another side effect of this is that is actually already in Power BI before we had crashing is files are refreshed with the data set refresh. And so basically you offload the queries to the time of refresh, not to the time of somebody asking to view a report. So that gives you basically both control of when queries are done and forcing function to create less queries when you don't really need them. The third one is shared datasets and certified datasets that was released a few weeks ago. That's a new capability in Power BI, both in shared and in Pro and in Premium, that allows you to basically have a lot less datasets. With import mode and with the naive approach of kind of using Power BI Desktop, you will see often multiple versions of the same report getting uploaded, and then data sets are being copied, but they're the same data set. And all of these same data sets are loaded into memory by different people and just consume resources unnecessarily from the capacity, where what should have happened was one data set loaded and everybody's using the same. So this is another forcing function feature that will allow you to guarantee that people are using just one version of any data that they need to report on, and not multiple of those. Aggregations, again, both on shared and Prime Premium, a great way to load a very thin layer into memory in the Power BI capacity and have all the data required for the reporting reside somewhere else. In this case, it's a Spark cluster. Dashboard, I touched that when I talked about caching. It allows you to offset the query load to a control time, which is the time of refresh. So consider that. And again, this is as slow as I can covering this because I think we're out of time. Are we out of time? 4 minutes, okay. So adapting content is hard because there's 2 sessions to watch and a lot of features to adapt. Can you get help for it? Yes, you can get help. We train partners on creating performance content for Power BI. AppSource, which is how you get the Premium Capacity Metrics app, is the way to kind of look for these partners that can help you with adapting content for better performance, and I have a link for it ready. Final question is about prevention, which we covered in a bit more depth yesterday. We're introducing very soon a number of settings beyond just the memory allocation for workloads in the admin portal for capacities. Those settings will allow you to control various properties of analysis services engine running in Power BI Premium that can guarantee that users performing or running bad DAX expressions or unoptimized content will not consume too much resources. So for example, we control the number of rows that a query can return. There was a question, I believe it was somebody in this area, about do we limit the number of rows? Yes, we would now be able to limit the number of rows a query can return, and somebody running the wrong thing could not screw out everybody with a runaway query.
The direct query result size, that's the max intermediate result set size. That's for direct query. It's defaulted to 1 million. You could change it up or down.
That's a new thing, yeah.
The fact that we're exposing is a new thing for Power BI, yeah.
It's
A few weeks. It's working its way through to production.
It's an actual screenshot.
Remember, just because you can doesn't mean you should.
And we wanted to highlight kind of few examples. I mean, you know it, I guess, but it's non-trivial to map these to actual use cases. So you have the kind of the phenomenon on the left side of the table here, in the right side of the table, the scenario, and which setting will apply for it. Are we releasing the interleaving as well? We talked about it in Christian way. Yeah, so. Yeah, there's in another session we talked about a new setting that's going to happen too, which is called interleaving. That will also allow you to kind of better fence yourself against multiple users. Some of them have really bad expressions, and the bad expression messing it up for all the other users.
We talked about during Christian Wade's session yesterday, if you looked that one up.
Yeah. So okay, the last slide I have for you guys to take a picture of because we won't get to talk about it. Kind of a best practice, because the premium capacity is subject to the level of optimal content that you have there. There's a best practice that we have recommended for a few customers that have met these challenges, and it's proved very effective. That practice is to basically have 2 capacities. So when we talked about production and development workspaces, extend that idea to capacities. And basically, if you have a development capacity where all of the organization can publish content to and kind of have the content park there and experiment and share it across, and everybody's watching it, and it's free licenses, and it's great. But then somebody that knows what they're doing and what to look for is looking at the capacity metrics app for that capacity and quote unquote approves a report to go to production. That somebody is the only person with assignment permissions on the production capacity, and they migrate the workspace for each project from the development capacity to production capacity, at which point it is safe to share with the CFO and the CXO and the CMO because you know that it's running optimally, it's not going to screw up, others won't screw up with it, and it has like it's safe sandbox running space. So if you take away anything from this, take away this best practice alongside all of the techniques of how to basically plan well and build better content, and just exercise those so that you're safe. Any question in a minute half left?
One last word, very important. So at this point, you guys saw that you can stress the capacity. You should have this question. I have users on my capacity already. Why and how would I add an extra load and not take the unit offline? Do you do it on Saturday, on Sunday? Please be aware of this fact. We have Azure SKUs, A SKUs. If you have a Pro license and you go on your Azure portal and you buy an A SKU, A1 will cost you $1 an hour. And
Yeah, but,
I can squeeze 5,000 renders, and that's not the limit. That's approximately 2 renders per second, even with direct queries or imported.
Yeah, but
Yep.
don't test on a A1. Use Azure for testing. Use an A4, which is a P1. A5,
A4
which
is an
a P2.
equivalent of P1.
Okay.
I was getting there. I was
Okay.
getting there. So be aware of this.
Once you give them an idea, they'll do it. Okay.
Half a core, so
Then,
too much for the half core.
there's a lot of nuanced differences that if you test on an A1, it would be unrepresentative of actually running on a P1, even if you multiply the results.
And even
Right.
though the P1
So-
is around the same price as the A1, A1's slightly more because you can. But the reason it's slightly more is because you can pause it. So when you're not using it, you can turn it on for an hour, test it, turn it off, and you're only paying for that.
Don't
hour. You
use
have to-
A1, use A4.
It's that A4.
You
can
said
pause it.
A1. Don't say it. Erase the term A1 from your brains. Stop saying A1. Yes. Hmm? Yes, that's covered in the metrics app. Well, you could just screenshots right now, and you can use something that is called Analyze in Excel, where you drop basically the data set underlying the metrics app in the specific time that you're viewing it, and create a report out of it.
We will let you share the metrics app very soon.
We will convert the metrics app to a template app, and that will give all the benefits of an app. Like you could be able to do anything you do in an app. Okay.
It's hopefully in the weeks time frame too.
Awesome. Too short. Thank you.